Broadcasting music with an Arduino? How is that possible? There's only the Arduino with a ferrite antenna and a few components. Is this a fake? No, it's real. An Arduino can generate frequencies up to 8 MHz. If a radio is set to AM, it can receive these frequencies. AM receivers require an amplitude modulated signal at their antenna input. In amplitude modulation, the amplitude of a radio frequency carrier signal changes in proportion to the amplitude of the modulating signal. So the first thing the Arduino has to do is generate this carrier frequency. For this we can choose between 3 hardware timers and counter units. Timer 0 is already occupied by the delay and millis functions. So I don't use it to avoid conflicts if I need those functions later. But I can safely use timer 1 and timer 2 for this purpose. I let timer 2 generate the carrier frequency. I configured the timer to increment every 125 nanoseconds until it reaches the value set in the 2 output compare registers. Then it toggles the level on its output pins and starts over. So the value in the output compare register determines the frequency. After initializing the timer, I force its second output to 1. This way I make the 2 pins turn on and off alternately. On the Arduino Uno, Nano or Mega, these are pins 3 and 11. Using this trick, we'll get an AC voltage between these pins that has twice the amplitude as if we'd only connected 1 pin. This gives us more transmit power. And we can just put a ferrite antenna in between. Of course, other types of antennas will also work, but I choose ferrite antennas because of their small size. I got this one on eBay. Now let's find an appropriate frequency. As I said, the output frequency of the Arduino timers depends on the value in the output compare registers. This gives us a bunch of fixed frequencies, most of which are in the medium wave band. Almost all AM stations have been shut down in the last decade, so we are not disturbing anyone and no one is disturbing us, at least during the day. However, there's a lot of interference from nearby devices, like my laptop power supply at 1000 kHz. Try it with your radio before you decide which frequency to use. Higher frequencies tend to have less disturbance. At 1600 kHz there's neither interference nor station, so I choose the appropriate register value for that. After uploading the sketch and tuning to this frequency, the noise disappears and the radio's receive indicator LED lights up. When I disconnect the antenna leads, the noise comes back and the LEDs get dim. Same thing happens when I move the Arduino away a bit. That's proof that the Arduino is indeed transmitting on the right frequency. But there's still no music, so how do we modulate the music? I got the Arduino to do that, but how? An amplitude modulated signal is basically an analog signal. So the question is, how do we get an analog signal out of a digital device like a microcontroller? Well, in general, microcontrollers use pulse width modulation to write analog values to peripherals. Although a PWM signal is still digital, it has the same effect as a corresponding voltage between 0 and maximum. What if we apply pulse width modulation to our carrier frequency? I use timer 1 to chop the RF. And this is how it works. The timer calls 2 interrupt routines. When it overflows, the first routine writes the result of the last ID conversion into the compare register. Then it enables the antenna output pins, giving way to the carrier frequency. When the timer hits a value in the compare registers, this interrupt routine turns it off. Now let's build it up. This time I use a pin-compatible Nano instead of the Uno. Then I need two 10K resistors. One goes from ground to analog 0, the other from there to the A-ref pin. The audio comes in through a capacitor of at least 1 microfarad. And the radio frequency goes through the ferrite antenna that I connect to pin 3 and 11. That's all we need to make an AM transmitter out of an Arduino. Here I'd like to thank the sponsor of this video, PCBWay. Not only they have provided me with high quality PCBs that are fun to assemble, They also made the 3D prints for my laser scanning microscope that I made out of a Blu-ray player. The parts are robust and fit together seamlessly. And since I don't have the Metalwork workshop, they also made a beautiful brass cover for my all-in-one meter. See how nicely it fits on the VFD tubes and holds them in place. And of course you can order all of the services online. So, all that's left to say is that PCBWay is the right partner for all your projects. Check it out. Let's connect my phone and broadcast some music. Picking a random song and tuning the radio. There we go. And it plays, the typical muffled AM sound. Sounds decent, but of course you cannot expect high fidelity from an AM radio. Let's hook up the scope now. And we can see the PWM modulated RF. Now we can play with the volume so that we get a maximum loudness but no distortion. The more we crank it up, the more the duty cycle wriggles.
Wiggle, wiggle, wiggle.
This is so amazing, isn't it? Let's see how far my DIY radio station can transmit. It's only a few feet. Can we get more out of it? A capacitor in series with the antenna puts it into resonance and improves the efficiency. Its value depends on the frequency and the inductance of the antenna. Instead of complicated calculations, try and error is the fastest and easiest way to find the right capacitance. This is where an assortment of different capacitors comes in handy. Or just use a tuning capacitor from an old radio. If you have an oscilloscope, connect the 100 ohm resistor in series and measure the voltage drop with the first channel and the input voltage with the other. The voltage across the resistor is proportional to the current flowing through the antenna coil. Then find the capacitance value at which the current reaches a maximum and comes into phase with the voltage. If you don't have an oscilloscope, put in two antiparallel LEDs and try until they glow brightest. It's a bit weird that the TX LED on the Arduino also lights up when it's in resonance. This may be because of some parasitic capacitive or inductive coupling. Whatever it is, it was not intended. But it means that we don't really need these LEDs on an oscilloscope. So the built-in TX LEDs are the perfect tuning indicators for our antenna. I also added a lithium-ion battery with a boost converter as a power supply. This way I have fewer cables in the way when I'm testing the range. Let's do another range test now. With the right capacitor value it transmits easily over my desk. I now pick it up and take it for a short walk. I'm 2 meters away and it already gets noisy. Now it's about 3 meters and I reach the wall and cannot go any further. So the range is less than 3 meters. Of course this is not a pirate radio station for an entire country. But it does a good job if you want to have fun with old AM radios. It's up to you to experiment with different antennas and amplifiers. Subscribe and enable notifications to never miss any of my videos. Also check out this one, where I show how to send data with an Arduino without using an RF module. Consider becoming a patron on Patreon to get access to sneak previews and other goodies. Thank you for watching.